Hello everyone, welcome back to In 5 Minutes. In the last session we have seen the source of faults. Okay, in this session we are going to see the types of faults from the different sources. So sources we have got. Now from that sources what kind of or what types of faults are there we'll see in this session with 5 minutes. Okay, so particularly there are two types, dynamic faults and static fault. We will see one by one. Okay, so very first type of fault that we have is the dynamic. So in dynamic fault, this type of faults may occur due to delays in various gates. Okay, so first point is delays in the gates from different family, delays in the logic gate, as well as the dynamic kind of, the name itself suggests the fault is dynamic. It may occur for some gates, it may not occur for the other gate. Similarly, while using the high frequencies, so next point is while using high frequencies, what will happen, there will be a shorting effect in between two lines which are close to each other. Okay, so high frequency, we know that due to the skin effect the current and voltage travels at the surfaces. Now if suppose there are two lines, okay, two tracks normally working, okay, at low frequency, so there will not be any losses in between these two lines, or there will not be a shorting effect. Okay, so this is called as shorting at high frequency. You can suggest this as shorting at high frequencies. Okay, so while using the high frequencies, what will happen, the circuit in which these two lines, particularly A and B, were working normally, okay, but when I use that, when this circuit is subject to high frequency, when we use the same circuit at the high frequency, what will happen, the energy may transferred from one to another and there will be occurrence of fault. Okay, it may pull down to ground state. Suppose this is at 0 state, this is at 1 state, so this 0 may pull down all the energy of 1 volt logic 1 to ground. All the energy is synced in the 0 line, so at A there will be a fault. Okay, this is also called as coupling effect. So the next point is coupling effect. This is dynamic in nature because some of the frequencies it works, some of the frequencies it won't work. So this coupling effect, using high frequency, some circuits may shows the fault, or there will be delays in gates for different gates, or different gates from the different logic families. So this kind of faults are called as dynamic faults. And moving on to the next session, that is nothing but the static faults. So static faults, they are observed at a particular spot. First, a particular spot is there. Now what happened at this particular spot means what, the circuit is working for all the inputs. For some of the inputs it is showing faults at particular, for some of the inputs it shows the fault for particular spot. Now this spot may be sinking more current than usual, there will be a significant heat generation is there. So this kind of particular spot mainly can be observed with the help of thermal imaging. So thermal image is taken out of the circuit while working, and significant heat spots are obtained for particular inputs. And if suppose some point is there which is having to show some higher heat signatures, that is nothing but there is a more current sink than usual, and hence a fault is detected at that point. So these are particular spot, or it might be possible that due to some misfunction or the defect in the device, so thermal imaging, or you can say device defects, there will be a static fault there. Next way, in the dynamic faults, what we say, at high frequencies the lines are coupled, but here shorting of wires takes place. That is nothing but shorting of wires due to close spacing. If two wires are placed closely to each other, it might be possible that the shorting effect will take place and these two wires will be shorted. Okay, so then there will be a fault. Okay, so these kind of faults are called as static faults. So roughly you can bifurcate the type of faults into dynamic and static, but to analyze these faults what we have is the fault models. Now these fault models are of two types. One is stuck at 0, another is stuck at 1. Some lines which will be stuck at 0 means shorted to ground, or stuck at 1, that is nothing but behave like shorted to plus VCC. Now this kind of models to be analyzed while solving the faults, whether it is dynamic or static. So for details on fault models, stay tuned to in 5 minutes, and thank you for watching this video.